So we continue with a speech by Mr. Stefano Rago. His speech is entitled A Developer's Journey into Building Automated Tests for IT from the Ground Up.
Thanks. So this presentation is about a practical experience that my team has had in the last couple of years. I think it's pretty generic. I mean, we will be talking about particular technology solutions because, of course, this is coming from real-life journey, so there needs to be something in place that works. But I believe we at Agile 42 believe that the approaches presented here are probably enough generic to be applied regardless of specific technologies. So I hope you will enjoy it, even though you don't use these solutions in particular. The presentation is about how we went from a certain approach to working and dealing with our infrastructure, which was pretty much manual, pretty naive, I would say, because we don't have a system administrator's background. We are software developers, so our main job is to code applications. But we found ourselves in the situation where we needed to run some infrastructure because we wanted to deliver the software to our customers. And so this infrastructure started growing, and eventually we decided that our simple, basic approach was not enough. And so we started looking into something, and things grew up, and we came up with a solution that I will present. So a little bit of context. I'm currently splitting my time between these two groups, these two companies. Agile 42 is the Agile coaching company, like we like to call it. And we do Agile coaching and training, and with them, I'm mostly doing technical trainings, Agile engineering practices, trainings, and workshops. Whereas with Agile Software, which is a spin-off of Agile 42, we develop tools, mostly web applications. Some of them are targeting Scrum teams, Agile teams in general. Some of them regard selling our training, so e-commerce platforms. And we recently started developing a platform to help Agile coaches interoperate and share their work. So what all of these web applications have in common is that they run somewhere on the internet, in the cloud. And there is some need for infrastructure and some configuration involved. And our scenario is pretty common, I would say. There's nothing probably too exotic. We need to configure users. On some of the machines, we need certain users, system users, real users, etc. And we want to group them so we can manage them easily. We also want to make sure that they only have the necessary rights on each of the systems or parts of the system. And also, we need to install some libraries because probably our application requires enough packages. But not only install them, also manage their versions, for example. If we need a specific version of a package, we need to be able to install exactly and pinpoint to that version, remove something that is no longer needed. And also, because our customers are actively involved in the usage of the applications and they produce data, we need to make sure that their data is safe and regularly backed up. So we need to configure our infrastructure in a way that this data is safe and we can recover in the face of failures. Also, more common things like managing email, sending out communication to our users, so we need to probably configure some mail agents, mail servers, smart hosts, and the like. And of course, who doesn't have them? Web servers. Not only the most common solutions like Apache and Nginx, but also something which is tightly bound to our particular application stack, which in our case is Python. So things like mod WSGI, micro WSGI, or GUnicorn, all of these needs to not only be configured, but also we have to make sure that interoperating with the rest of the components as expected. And we want our applications to perform in the best way possible. So the least we can do is provide some caching solution in our infrastructure. So for example, we've been using Memcache or Redis, for example. And also, because the internet is a mean place, we want to have a decent level of security all across our infrastructure. But in spite of all that, things can still break. So we want to, of course, monitor everything, all the machines, all the infrastructure, all the services that build our end product. And we want to be notified as soon as possible if something goes wrong or is going to go wrong before it impacts the services and the users. And as you can imagine, this is just a small part of what's involved in all this scenario, and there is much more than that. But alone, these components are enough to give an idea, even though this scenario is not particularly complicated, it's web applications after all. It's enough complex to require an approach to managing infrastructure that is not, of course, not manual. We don't want to SSH in each and every machine and configure every single component. And also, we want to reuse probably configuration. So compose pieces, refactor parts that are common. And this sounds familiar to us. These are all problems that we are used to deal with, and we are familiar with because we've been doing software development, and certain principles like object orientation are very clear about this kind of problems. So we started to see some kind of similarities. And we started to looking at alternatives, at how we were managing our own infrastructure. It was pretty clear to us that infrastructure as code was the way to go, not only because we are used to coding, but also because we have seen that the community has shown recently a certain interest in several configuration management solutions that use code. This is the number of questions being asked on Stack Exchange. I used an API that they made available on their website, and you can ask this API how many questions have been asked in this particular year regarding this topic. For example, Chef or Puppet, I reported here only some of the most common, but I had similar results for other solutions. So let's go with infrastructure code, we said. And since this is code, we grew up with the notion that any code that is not tested will be broken. So the least we can do is have some kind of testing, automated testing in our case, that can give us some confidence that what we are writing is not only working when we write it, but also it's evolving in a consistent way, and the expected behavior is still consistent. So this was a pretty trivial question for us, but we've seen that the community didn't show as much interest in automated testing solutions. As you can see, the blue line there is pretty low compared to the number of questions regarding the infrastructure code solutions by themselves. Anyway, for us, there was no way we would go on writing code without testing it. So the more interesting question for us was if we could write tests before coding during our day-to-day infrastructure code activities. And this is basically a test-driven development, what we're talking about, which is something that we embraced right from the start, and we've learned that is bringing a lot of advantages when it comes to dealing with code. But since this was going to bring another layer of complexity, we are already going to bear the load of a new stack, new technologies, new languages, something that we never dealt with before. Having another layer of complexity needed to be justified. So we started looking at what we saw when doing application coding that was benefiting from using TDD, and the advantages are many. But the most important is the reduced cost of maintenance, meaning that when you have a code base that you need to maintain and develop and improve, when you have TDD and you develop this code using TDD, you don't spend as much effort and time maintaining it. And this is for a number of reasons. First of all is that when you do TDD, you use an outside-in approach, meaning that you look at the problem from the point of view of the user or the part of the system that is going to use what you are about to code. So you have a different perspective on what you're developing, and also you write something that is exactly to the point. You don't digress. You don't write something that you're not going to need, which is probably happening often when you don't have a clear focus. And this improves the overall status of your code base. And also, you tend to have code which is not bound. So several parts of the system are not bound to each other. When you have to do a modification to some part of a module, for example, you don't have to worry about rewriting all the parts that are dealing with this, because you have clear interfaces. When you approach writing the code with the test first, you define basically an interface. And so it's much easier to refactor and to take care of this code later on. And you end up having a safety net, because the tests that you write are always kept up to date. So whenever you want to make a modification and you want to change small to medium or large parts of your system, you always have a confidence that your tests will tell you if you broke something. And this gives you a very fast feedback. You can develop much faster in this way because you have the confidence. You don't have to go and check every time you make a change. So in the end, you have a well-designed code, something that it's easier to maintain and it reduces the costs. Another important advantage of doing TDD with application code in general is that you have documentation for free, basically, because you can just look at the tests at any level of abstraction and read what the system is doing. So, for example, if you take an end-to-end test, it's almost human language. You can read the features. If you do BDD, for example, read the features and understand exactly what the system is expected to do and how it's behaving. And if you need something more detailed, you can go and look at unit tests, for example, to understand what a module or a function is doing. So it was pretty obvious that in spite of all the effort that we were going to face, TDD was going to help us a lot, especially because we didn't have such a strong background of system administration. We needed a safety net from the tests. So we decided that our main goal was to have a continuous integration system that will run, every time we will make a change to the code, will run all the tests at all the different levels, unit test, integration, or end-to-end, and give us a feedback about what we were doing. And also some side tasks, like, for example, checking that the code that we're pushing is following conventions, for example, like styling, or is not introducing unnecessary coding or breakpoints, for example, that we don't want to integrate in our code. So, the building blocks of this setup are main 4 blocks. So, of course, we need a configuration management, no way around that. And we need a way to test it. A testing framework is basically taking off our shoulder the whole effort of isolating tests, making sure that the states are cleared up between each test and the tests are representative enough. Their outcome is not depending on what has been running earlier. And we want also a way to execute these tests in a continuous integration environment, because there's probably going to be several people who are writing and contributing to the code base. So we need to put all these efforts together and run the tests, again, the combination of them, and not just our particular environment of the developer, for example. And we want to run all of this in a virtualized environment because, of course, it's much more convenient and also probably enough representative of production environments because they anyway run on virtualized infrastructure. The particular solutions we picked are Chef in the case of configuration management, which is a tool based on Ruby, and it also provides a testing framework, which is called Test Kitchen, and is not only targeting Chef, but also other different configuration management tools. For the the continuous integration part, we picked Jenkins, which is probably one of the most common open source continuous integration solutions. And for the virtualization, we decided to stick for the time being with what was our infrastructure at the time. So virtualization by means of the KVM and managing their high-level lifecycle with Vagrant. So I mentioned that there are different kinds of tests in application code, but this applies as well for infrastructure. And we have the so-called testing pyramid, which sees the unit tests at the base. So you have a large number of small, rapid, quick tests that give you a very precise feedback about what's going wrong. If something fails, you know exactly where to look for, and are very fast. And then you have integration tests because, of course, we cannot think that if millions of units are working in isolation, they will still work when integrating them with others. So integration tests do just that. They make sure that a module combined with another is producing the expected result. And if we bring this discussion even further with the abstraction, we end up with the end-to-end tests, which are the most costly kinds of tests because they involve the setup of the whole system. So they will probably take time to not only run, but also maintain and write. So that's why the pyramid is built in this, has this shape here. And for the particular solution that we picked, there are equivalents for each of the layers. So Chef spec is for the unit test, and server spec for integration and end-to-end test. In particular, Chef spec is very fast because it doesn't need to apply the configuration to a real machine. So it builds an image simulation, let's call it, of the virtual machine in memory, and so it can run and make assertions very fast. But of course, this is not representative of what we want really test end-to-end. So we have server spec that allows us to spin up a real machine and makes assertion from the outside. So, for example, SSHing into it and checking that a particular port is listening or a service is running, for example, for real, not simulating it. Okay, so I prepared a little demo to show you the concepts I've been talking about. And this demo involves a continuous integration system which is running on a virtual machine on the laptop that I'm using, and also is using a Git repository to simulate the integration part and the code sharing part. What else? There is a slave, a Jenkins slave, which is running the tests, also running on this machine. Okay. Can you read from the back? Yeah? Good. So what I have here is a test, an end-to-end test written in server spec that I prepared, which is checking that the system has a particular cron job installed. And the cron job should run an executable, which is somewhere on the file system, in every minute in this particular case. And the cron job should run with the JSmith user. So I already pushed this to the continuous integration, and now I will run the build. As you can see, the output is quite verbose, but we configured it in a way that can be easily parsed by Jenkins, and at the end, all the tests are summarized in the results. So we have one failure as expected. And the failure is about the cron job that we wanted to be present on the machine, and the test ran and it didn't find it. So as you can see, I hope you can read it. It expected to find the cron job entry, and it couldn't find it. So let's go ahead and fix this. The first thing we see is that even in this very simple example, we have more than one part, one unit, we can say. So there is at least an executable that we need to have on the machine. Also, we need a specific user that we want to run the cron job with, and of course, the cron job itself. So we need some unit tests, probably more than one. The first I would write is, for example, the presence of the executable file on the machine. I will run this test on my local machine because the idea is that I want quick feedback, and I'm test driving the development, so I don't need to push something that is not complete yet. So as expected, we have 2 examples and 1 failure. Okay, the first example is the default that gets created and is checking that the basic provisioning of the machine is working, so that passed. But what didn't pass is the new one that we wrote, and we expected it to fail. But we are following this path in TDD because we want to make sure that the reason of the failure is exactly what we expected. So we let the test drive our development. If something else failed in this example, we will have to focus on fix that first and then move on with our initial goal. And this helps keeping us focused on the goal, as we said earlier. So now that we have a test failing, we can go on and create the resource that we need. This is how you do this in Chef, and run the test again. Okay, now we have to take care of the cron job itself. So let's write another test. And we can call this cron job arbitrarily, so I just choose foo. But we want to make sure that this command runs, this job runs exactly the command that we are looking for. I think I made a mistake, sorry. Okay, this is basically the syntax that we use to express the fact that the cron job should run executing a specific command. Okay, we have a failure, and if we look closer, the error is that it expected the cron job on the machine, but it couldn't find it. So now we can go on and create it. Now we have all of the unit tests running and passing. So let's suppose that we push this to our continuous integration server. and see what happens when the end-to-end test is executed. So I'm pushing this now to the repository, and I'm triggering the build in Jenkins. So as you can see, one of the things that the provisioning did is creating the cookbook file, but it just tried to create it, actually. It failed because it didn't know what this file should be. We didn't specify what's the content of the file, or if it's an existing file, where should it look for it. So this is something that the unit test didn't cover. In this case, we can use Chef's capability of finding the files in well-known paths. So I can just create one. It's an empty file for the sake of the demonstration, but of course here you will have to add something meaningful. Pushing again and rerunning the test. So the Converge, this time, managed to create the file, and it updated its content with empty string in this case, and it also managed to create the cron job. So after the provisioning is done, the verify command is executed, and it will run our initial test, the one we started with. Okay, it failed again. It didn't find the cron job, but this is because the command that it's using to find the cron job involves the checking for the user that we wanted to run the cron job with. So this is another problem that the unit test didn't catch. But now we write a new one that checks that the user exists, and then that the command, the cron job, is executed with that particular user. Again, we want a failing test first. Okay. It expected the user, but it couldn't find it, as we knew. So let's go on and create them user. Now the user is there, but we also want to enhance our previous test to make sure that the test is not only checking that the command is correct, but also that the user is correct, because we've seen that this is something that escaped our initial testing. Rerun the test locally. The idea is that when the unit tests are not passing locally, we don't even push to continuous integration, because it would cause broken state in the repository. Okay, now all the tests passed except for the one that checks if the cron job is being executed with the right user, and it's not. It's using root instead of jsmith, but this is of course normal, because this is the default chef behavior. If you don't specify anything, it will use root. So let's specify jsmith instead, rerun the test. And now we can push. Let's see what's happening under the hood. So the provisioning started. It created the cookbook file for the executable. It created the cron job. But it failed. So if we look at the summary of the result, we can see that there is a particular failure, and we can understand that our current state of the code is not correct. So if we were going to production with something like that, we would be causing probably an issue. If nothing else, the cron job wouldn't be executed. And then if there is something that depends on that, there is potential failures that follow this event. So the fact that we have continuous integration in place that is blocking this and preventing us from going into production with something like that is of course a huge benefit for us, because first of all, we don't cause downtime, and also the fact that we have this feedback right away when we are developing the feature reduces the time to fix it, because we just wrote the code. If we had to fix some code that we wrote, I don't know, a month ago because some user called support and said, hey, there is this problem, we had to go back and fix it, and it takes a huge amount of time compared, of course, to fixing it right away. So this is a big benefit. Let's go back to the slides so I can conclude. So yeah, the benefits of this setup, we just saw one, and there are many. So we discussed reduced cost of maintenance, we discussed the improvements over the code base that this approach can bring, and there are many more. Of course, there are also limitations. For example, the fact that we are running some tests on a real virtual machine require some time, not only to write them, but also to maintain them and to run them, because imagine that you have to spin up a real VM. Maybe you can use some fancier technology, containers or something in the cloud, not necessarily the solutions we've been using. But anyway, this will imply some costs. And our journey has just started, and we want to get over all of these problems. So performance, also bringing further the discussion of abstraction layers between tests. So what for us is now an end-to-end test, because it involves a whole machine, it can become a unit test if we think of a machine as a unit that is interoperating with other machines in orchestration tests, for example. So there's much more than what we're doing now that can be done. Performance improvements, more levels of testings in general. So our journey is basically at the beginning, and we want to bring it much further. There is just one resource that I would like to recommend, which is this book from Stephen Nelson Smith. And this is where our journey started. So it contains lots of interesting concepts about applying automated testing and test-driven development to infrastructure code. The only part that is missing, and we probably had our added value in our journey, is the continuous integration part, because once you have tests running on your machine, is a good situation, but you don't want to be forced to run these tests every time you make a modification, because these are very expensive, and also you probably don't test your changes in integration with the rest. So continuous integration is necessary for us. At least this is what we've learned doing application code. But still, this book is a very good starting point, so I highly recommend reading it. And this is it. I would probably push all the slides and the code if you're interested. I will tweet about it. So here's my handle on Twitter. And if you have any questions, otherwise I'm finished. Thanks for your attention.
So next on our agenda, we will have a word from our sponsors. I would like to invite Electric Cloud General Manager and Vice President Deployment Solutions, Mr. Wesley Pullen, for his speech on behalf of Calitech and Electric Cloud.
I have very limited time, so I do something very quick and I make an announcement. Again, my name is Wesley Pullen. I work with Electric Cloud, and we're partnering with Calitech to bring you something that is very exciting. It's called Electric Flow, and it's a solution that allows you to do application delivery at very significant scale, build pipelines, and really have a structured way of accomplishing continuous delivery. This is the world I came from. I started as a developer. I have always been and will always be a developer at the heart. I worked with IBM. I also worked with Accenture in the United States for many, many years. And basically, software delivery has changed in quite some time. When I got started in development, I don't want to date myself, I'm only 20 years old, but I've been in development for over 25 years, so you can do the math. It was like the picture on the left, big monolithic systems, and they were very large. In today's world, including containers and microservices, we have significant amount of services, significant more delivery, more agile practices. So we've got to be better in how we handle the challenge. This is the world that most people live in when it comes to orchestrating DevOps and doing DevOps. There's a lot of teams and a lot of constituents, and the objective is to move far to the right in a way that's continuous, in a way that is solid, in a way that it can be tested. Where Electric Cloud will sit is in the middle. Providing release automation, but also helping you do continuous integration, continuous tests. Someone mentioned Jenkins and DSL and Chef. All these technologies are just one of many in the life cycle of software development in today's world. So, in the interest of time, I show you a little bit about the architecture. I only got about a few more minutes. So the best way to explain this, me being a developer, is to shift the picture to the right and say that what I'm used to in code is now a model. When we build trains, when we build airplanes, Boeing 737, when we build buildings, much like this, we have an architecture of what it needs to look like. As a developer, I'm the type of guy who would never use a user interface. I would use something a little bit more modeled like this, where I'm running in Vagrant, where I can spin up a VM very easily by a few commands. This is the excitement around Docker and Kubernetes and Rocket. So me being a developer, I can represent everything I'm doing in what we call DSL, domain-specific language. Jenkins has DSL, Chef has DSL, many other technologies has DSL. Electric Flow is one of the first release automation technologies to offer developers DSL to author and create everything via API. You don't have to use the UI. So we talk about DevOps. Ops may need a more UI-centric way of representing applications, their static and dynamic environments, and ultimately a pipeline. But from a developer perspective, it may look like this. If I have an example for you, let's see. Yeah. I'll shrink it down really quickly in the interest of time. This is my world today. It's more like this, where I have a really structured, easy, groovy-based language where I can represent all the models and all the visuals you just saw strictly in code. In the interest of my time, since I'm just about out, we have taken the liberty to provide you a community edition free of charge, even as a closed source vendor selling software. We provide developers, everyone in the room, your own instance of using a virtual appliance where you can take the power of DSL, take the power of Electric Flow for free, unlimited, as long as you want. So that's part of our quick announcement. Let me end to give you some information on that that we are providing. This is the announcement. It's a virtual appliance, and this is how you get it. It's a free community edition. You can download and play at will. You can go to the location on the right-hand side to be able to use it. Full DSL editor, full DSL capabilities, Groovy specific, and you can build pipelines and orchestrate DevOps to your heart's content. Thank you so much for your time.
Thank you very much, Mr. Pullen. Now we have another word from our sponsors. Please welcome Amazon Web Services Enterprise Lead, Mr. Mert Doğu, for his speech on behalf of Amazon Web Services.
Hi, everyone. Let me try to quickly set this up. Okay. Thank you for listening. I have only 5 minutes, so it's going to be quick. What I'm going to try to do is talk about an idea and give you 1 or 2 examples that I hope will excite you a bit and maybe get you to try some of the stuff out on AWS. My name is Mert Doğu. I'm the enterprise lead for Amazon Web Services here in Istanbul. I've moved to Istanbul in December 2015 when we opened the office here. I'm very happy to be here today. Okay, so I said I would be talking about an idea. The idea is that if you want to be innovative, you have to reduce the cost of failure. So people should not be afraid of making a failure because it costs too much, because that hampers innovation. Now, our company, Amazon, has actually adopted this idea among many others and has started in 1994 with a very simple web page and has grown into a Fortune 500 company, and the web page looks like this in 2015. In order to do that, they have actually created this platform that's reliable, scalable, secure, but most of all provides cost effectiveness. You pay for what you use. You grow, and you only pay when you grow with the growing potential that you have on AWS. Now, when AWS created this innovation platform, they thought this is so useful to us that if we were to make this available to other customer segments, they would benefit from it as well. And that's how Amazon Web Services started in 2006. Since 2006, and it's been about 10 years, the company is now a $10 billion company growing about 70% per annum, is providing cloud services as they're known now. At that time, it was web services. And you can spin up servers, databases, but also serverless infrastructure and do DevOps on AWS for a fraction of the cost that was available before cloud was there. So this enabled many companies to invent new businesses, right? New business models. And they are currently today called disruptors. These are some of those companies. And these, by the way, run all on AWS. And I would like to, as a second example, after giving the example of Amazon, maybe dive a bit deeper into Airbnb, which some of you might know. Airbnb hosts about 150,000 people every night. And it started doing that, about 6 years ago. And in 2013, they had about 4 million subscribers. In a year's time, they actually grew to 15 million. That's a tremendous growth all of a sudden. And of course, with that growth came the growth of their infrastructure. EC2 is the name of servers in AWS. So virtual servers that we provide are called EC2. So they had about 24 in 2010, and they actually had 1,300 EC2s in 2014. So, okay, what does that got to do with AWS? Why AWS? Airbnb has 5 people that are managing those 1,300 EC2s. The rest of their technical group is actually concentrating on trying out stuff, making things anew for their customers so that they can reinvent the market segment. So Airbnb is currently competing with the Hiltons, with the Sheratons, things that we know from when we were kids. These guys have come in 5-10 years' time, have actually redefined how business is being done. And it's not just Airbnb or a couple of companies that are doing this. We have companies from startups, and these are all AWS customers. We have customers in enterprises, because enterprises also see that they have to change the way they act and they have to do something faster, newer, adopt DevOps in order to be able to differentiate themselves. And there are many that are actually using AWS, which is also shown in this quick graph. You might have seen it. This is from 2015. Gartner is doing a Magic Quadrant for infrastructure as a service. There are 15 companies there. Amazon Web Services is one of the leaders and visionaries there, as it's always been in the previous years as well. But what's important is there are in total 15 companies here. If you were to take the 14 outside of AWS and add up all of the computational power that their actual customers are using, right? Multiply that by 10. That's how many computational power in AWS is actually being used when this report was written, in 2015. So that's how many customers are actually choosing AWS, and hopefully we're delivering value to them. I hope that we will be able to deliver value to you as well. In order to get a glimpse of what AWS can do for you, we have some credits out in the booth. So if you were to kindly come by, we'd be happy to give it to you. And just give it a go. If you like it, we would love it. If not, you tried it, and that's all the point. You try it, it's simple. If it works, it works. If it doesn't, you do something else. Thank you very much for your time.
Thank you very much, Mr. Do. Next, we have 3 ignites from 3 distinguished speakers on our agenda. I would like to invite Mr. Çağdaş Şenol, Ms. Seçil Kavas, and Mr. Simon Poulton to the stage. Okay, our first speaker is Mr. Çağdaş Şenol.
Hi, I'm Çağdaş Şenol. I live in Germany and work in Zalando. Zalando is a public company in Germany, and it's one of the biggest fashion retailer there. And so, since it is a public company, from time to time we have IT audit process. So these IT auditors can sometimes be annoying. So that's why I call them as a metaphor, busted operators from hell. But still, it is possible to deal with them as long as you can answer their questions. So we have some best practices in Zalando to answer their questions, but this talk will focus on only 4 aspects, 4 questions they will ask, and so that they, as long as we answer this question, they allow us to deploy into AWS directly. These questions are: which code was running on AWS at a specific time, and who deployed it and who approved this deployment, who made last changes to this code, what was the reason for this code change. Okay, you should use CloudTrails for that purpose, and you should analyze CloudTrail logs as immediately once they come, and if there is any suspicious thing, you should notify developers before auditors come and solve the issues. Okay, you should use infrastructure as code so that you can also answer questions regarding your infrastructure, not only your code base. So this will make life easier for both sides. Okay, you should also use immutable stakes. It's also very helpful for both sides, because since you do not change anything on the stack, and you don't have any history there, so you can always answer the questions fairly that what there was running, and you should always use, if you use Docker, you should use Docker with immutable tags. You shouldn't overwrite any tag, and by default, Docker latest is mutable. You should avoid it at any cost. And you should always annotate your Docker image with some ticket issue or SHA commits. You can use Docker label feature for that one, as well as you can tag your Docker with some SHA, and also you can put a metadata file into your Docker. And you should always apply for ICE principle whenever it's possible. So it's not only your code reviews that someone gives thumbs up, but you should also do it on the deployment process as well, and log it somewhere. So now this is how we deploy in Zalando, and it's usual that we have a ticketing system. In that ticket, in each commit, we refer to a ticket, and then we build our Docker images. In this Docker image, we have a metadata file with information such as committer ID, or the latest commit, author, or SCM URL, and then we build it and then push it to our immutable Docker registry, which is complete open source, and we also have our application registry, and there we, for each new version, we create a new version there, and which actually refers, has a pointer to the Docker image. Then we deploy to EC2 with cloud formation, and so with user data, by using user data, EC2 pulls the Docker image from our Docker registry, and we can answer the following question. Since we know at a given time which cloud formation stack was there, we can answer which code was running on AWS at a specific moment. And next. Okay. Since we have this metadata information in the Docker itself, we can also answer who deployed it. Since we registered the application in the application registry, we can also answer who deployed it or who approved this deployment. Since we have this metadata file, we also know which commit was involved in this Docker image lately, and since we also know this ticket ID, we can also answer the last question, which is, what was the reason for this code change? So by answering this question, actually, any developer can deploy the code to AWS, and this is very efficient in our case. So they are just auditors, so keep calm, and it's the only auditors, and for these purposes, we have our own infrastructure tool, which is completely open source, and it's called Zalando Stubs. It's on GitHub with Apache license. You can get inspiration, or you can fork them and play with them. And yeah, if you like these issues and want to learn more about it, I am around. And if you are interested in Zalando, so I can say we make offers you can't refuse. And thank you.
Thank you very much. Now we have Ms. Seçil Kavas on the stage.
Hello everyone, my name is Seçil Kavas. I'm really happy to be here with you today. I'm going to talk about some tips for project managers in DevOps culture. By the way, this is my first Ignite try, so I hope I will cope with it. First of all, I want to give brief information about myself. I am working as a business analyst manager and providing consultancy services in analysis and project management fields. Today, we are going to talk about some trends and some project management methodologies in DevOps. And this is our agenda. And here you can see some keywords. Please don't hesitate to contribute via your tweets. I want to introduce you the all-in-one man. He is a famous figure in 90s in Turkey. And he is famous for carrying everything on himself just in case. Some statements in new methodologies and new technologies make me to remember this man. Because methodologies like DevOps, Agile, and Lean methodologies encourage people to learn each other's job and do each other's job. And some methodologies encourage you to be a team, and the teamwork is important in this time. But general methodologies like traditional methodologies, legacy waterfall, there is also a team in this time, but these methodologies do not encourage you to be a part of a team or communicate with each other. So as a result, there is a black hole between test and the PPS processes, at least for the view of the project managers, analysis, and the testers, because you are finishing something and you are drawing it in a black hole. So what is in this black hole and what can be done in here? In the black hole, there are not just ops engineers. You can't blame or you can't hold responsible everybody, just ops engineers in these processes. And the tooling is not the solution in this process also. You can't just buy, expensive tools and set them into your company and then just sit and wait for your success. That does not work. So what do you need in this black hole? You need is a cultural change, a shared goals, and defined goals to work with together. And here the keyword is the collaboration. You should communicate with each other and you should understand each other. And also in this black hole, you should measure your success. Otherwise, you can't understand where you are doing well or not. You should understand by measuring yourself. So these points, one by one, bring us that we still need, in DevOps culture or in some agile cultures, we still need PM, at least to define minimum viable products or KPIs or project and priorities of your business. So being in a DevOps team, being in a DevOps structure is really excited for Dev and Ops people, but if you are a PM in this world, you must be careful about some threats, because the Dev people want to be quick and the Ops people want to safe and stable. From their nature, of course, you must be really careful. So around the world, there are some team structures, and I have listed 3 of them here. If you are working in a close-knit collaboration, this means you have Dev and Ops people, and they can understand each other and do their jobs one by one. But if you are a PM, you must be careful about no Ops trait, because since the people are able to do each other's job, then in a while the Ops culture can be disappeared, and one person can be overwhelmed. And the second one, if you are a big enough company or if you have enough money, you can combine a dedicated DevOps team, which is a bridge between Dev and Ops people. And again, PM must be careful about the communication and collaboration issues, because you have created one more unit between your Dev and Ops people, and you must be careful, you must be sure about misunderstandings. And also silos in here, you must be careful about. And the last and the most desirable one is cross-functional team, coming people from different disciplines. As I say, this is the most desirable in DevOps culture. But if you are a PM again in this structure, you must be careful about communication, because people are coming from different expertise levels and you can't just put them together and expect them to create a wonderful work. And you must define the single roles. I don't mean that you should say that, okay, you must do this and you must do that, but you should firstly define the single roles and people should choose what to be. I have tried to give a brief information about project management in DevOps culture. I hope you enjoyed it, and thank you for your listening.
Thank you.
As you
And we
can see,
have
it's-
Mr. Simon Fulton on the stage.
Sorry, overtalked the speaker. As you can see, it's quite difficult. It's like a carefully choreographed dance, getting the timing right. I called Beyonce, but she didn't take my call to help me. Anyway, my name's Simon Polton. I'm the Continuous Delivery Evangelist for CA Technologies, and today I'm going to talk about measuring DevOps. Why do I want to talk about measurement? Because I think we're all here because we love DevOps, right? We're passionate about DevOps. We want DevOps to rule the world. Now, if we want DevOps to take over the world, we need to convince our customers, our friends, and our families just how good DevOps is. So what we really need to do is think of a way to prove the goodness of DevOps to those around us. Now, if we're going to take a scientific method to prove, if we're going to find a way to prove this well, what we really want to do is measure things, right? That's the scientific measure. We measure before and after, and then we have proof to give people to show them that we're doing a good thing. So I'm going to speak about a concept very quickly I hope you're familiar with. It's called CALMS. It's a set of indicators for DevOps, to measure DevOps. So you've got culture, you've got automation, you can measure how much lean activity you're doing, but more importantly, from my point of view, you've also got measurement and sharing. So these two aspects are very, very important. So the next question, right?